answering question from KMM Set 1, 2023-2024. So my question is number 3. Thiocyanate ion, SCN, is an antioxidant and a useful therapeutic agent. A. Draw all the possible Lewis structures for SCN ion. B. Determine the most plausible Lewis structure and explain your answers. C. For the most plausible structure of SCN ion in B, illustrate the hybridization of the central atom and the overlapping of the orbitals. So first, let's start with question A, which is to draw all the possible Lewis structures for SCN ion. So, in order for us to do questions which is about drawing Lewis structures, first of all, we need to make sure that we calculate all the valence electrons of the ion or the molecules. So first, we have SCN ion, which contains sulfur, carbon, and nitrogen. So we have to calculate the valence electron in all these three. So first, for sulfur, it has 6 valence electrons, carbon has 4, and nitrogen has 5. So the total would be 15 valence electrons, and then we have to add another electron, which is because we have SCN minus ion. So therefore, we have to add 1 electron, and then the total would be 16 valence electrons. So, to draw the possible Lewis structures, first of all, we need to have the structure first. So C would be the central atom, and would be the terminal atoms. And then for the first structure, we can see that S forms a single bond with C, and then nitrogen would form a triple bond with C. So this would be the first Lewis structure. And then for the second Lewis structure, the S will form a double bond with C, and nitrogen will also form a double bond with C. And then for the third Lewis structure, the S will form a triple bond with C, and the nitrogen will form a single bond with C. So in order to draw Lewis structures for ion, we have to add this bracket, and we have to show the charge of the ion. Moving on to the second question, which is B, to determine the most plausible Lewis structures and explain your answers. In order to answer the question, which is about determining the most plausible Lewis structure, we have to calculate the formal charge first. We can calculate the formal charge by using the total number of valence electrons minus the total number of lone pairs plus a half total number of bonding pairs. So for the first Lewis structure that we drew, so the formal charge would be for S, 6 valence electrons will minus 6 lone pairs in sulfur, plus 1/2 2 bonding pairs in sulfur, and that would equate to -1. Then for carbon, the 4 valence electrons in carbon will minus 0 lone pairs in carbon. As you can see, there is no lone pairs in carbon, plus 1/2 8 bonding pairs in carbon, and that would equate to 0. And then for nitrogen, the 5 valence electrons will minus with 2 lone pairs in nitrogen, plus 1/2 6 bonding pairs in nitrogen, and that would equate to 0. And we can use this formula to calculate the formal charge for the first, second, and third Lewis structures that we got before. So for the second Lewis structure, we can see that sulfur has a formal charge of 0, carbon has a formal charge of 0, and nitrogen has the formal charge of -1. And then for the third Lewis structure, sulfur has +1 formal charge, carbon has 0, and nitrogen has -2. So when we talk about formal charge, the best Lewis structure is determined by for those structures, that has the most minimum value of formal charge. The best value would be 0. So, in order to determine the best possible Lewis structure, we have to look at the formal charge of each atom in the Lewis structure. So in this case, the second structure will be the most plausible structure. This is because nitrogen is more electronegative compared to sulfur. Therefore, it is better suited to have the -1 charge, because when we look at structure 1 and structure 2, sulfur has -1 charge. Meanwhile, in structure 2, nitrogen is the one that has a -1 charge. So we will choose structure 2 because nitrogen is more electronegative compared to sulfur. Moving on to question C, which is about, for the most plausible Lewis structure that we got before in B, illustrate the hybridization of the central atom and the overlapping of the orbitals. So we got this Lewis structure from B, which is the most plausible one based on its formal charge and why it's placed like that. So, in order for us to get the idea to draw the hybridization, we can do it by determining the class, electron pair arrangement, molecular shape, and total electron pairs, which can let us know about the type of hybridization that we will draw later on. So based on our Lewis structure, we can know that the class of it is AB2. Therefore, the electron pair arrangement and the molecular shape would be linear. This is very important because we can use it to determine the shape of our hybridization later on, which would be linear. And then the total electron pairs is 2. Therefore, our type of hybridization would be sp. So based on our Lewis structure that we got, we can see that S has double bond with C and nitrogen also has double bond with C. So this would equate to 2 sigma bonds, one between S and C and one between N and C. And then we will also have 2 pi bonds, which is also one from S and C and one from N and C. So first, in order to start answering questions about hybridization, we need to draw orbital diagrams for each atom. So first, for our central atom, we need to know the orbital diagram at its ground state, excited state, and hybridization. So our central atom is C. So at carbon in ground state, the orbital diagram would be like this: 2s, 2p. So as carbon has 4 electrons, this carbon has 2 unpaired electrons and can only form 2 sigma bonds with s and n orbital. As we need to form 2 sigma bonds and 2 pi bonds, therefore 1 electron from 2s orbital will be promoted to the unoccupied 2p orbital, and therefore carbon at its excited state would be like this. And then, for carbon hybridization, the mixing of 2s and 2p orbital will form 2 hybrid sp orbitals, and 2 of 2p orbitals remain unchanged. So as you can see in these 2p orbitals, there are 2 which remains unchanged and it is unhybridized. So this unhybridized will be used to form the pi bonds. Meanwhile, 2 hybrid sp orbitals would be used to form the sigma bonds. And then we also need to draw the orbital diagram for our terminal atoms, which is sulfur and nitrogen. It would be like this. So as you can see, both sulfur and nitrogen has 2 unpaired electrons. Finally, this will be our hybridization. So the shape of our hybridization would be linear, which is same as the electron pair arrangement and the molecular shape of our Lewis structure. So this is S, carbon, and nitrogen. And it will form 2 sigma bonds and 2 pi bonds. So the sigma bond would be 1 sigma bond from sulfur to carbon, 1 sigma bond from nitrogen to carbon, and also 2 pi bonds, which is 1 pi bond from sulfur to carbon, and 1 pi bond from carbon to nitrogen. That is all. Thank you.